Hello, dear friends, students. Hajarimal Somani College, final countdown. That's all. The error in the measurement, the sides of the rectangle is 1%. What is the error in the side? What is the error in measuring the area? Okay. So area stands as length into breadth. When the quantities are divided, the relative errors are always added. So dA by A is equal to dL by L plus dB by B. Of course, 100% comes. So it's 1% plus 1%. They're going to be 2%. Will be the answer. Let's go for the next. Which of the following is a vector quantity displacement? Shell is fired at an angle of velocity 196 meter per second. The time of flight is equal to u sine theta upon g. U comes to be as 196, well-arranged number. Sine theta, sine 30 upon g will gonna be 9.8. 196 is always double of 9.8, so I'll get 1960 upon 98. Sine theta will gonna be half. 98 to the 20 is 10 meter per second. 10 meters. 10 seconds. Time of flight. A force of 1 kilogram weight is the force on 1 kilo. So 1 into 9.8 Newton. So which is around 9.8 Newton. Around precisely 9.8 Newton. The value of the acceleration due to the gravity is maximum at the polar regions and equatorial regions. So whenever the object is over here, it is pretty much close to the distance, the center of the Earth. So at that time, distance and the gravitational acceleration, the formula is gm upon r square. So as the r is less, g is max. Again, for the depth, I think it is gm upon r minus d the whole square or something is there. Forgot the derivation. So as you are close to the center of the Earth, the gravitational acceleration is max. So at the polar regions, when you are close to the center of the Earth, then compared to the equatorial region, therefore, at the polar regions, the gravitational acceleration is max. The change in dimension is known as strain. Change in dimension to the original dimension is a strain. The internal restoring force per unit area is called as a stress. A constant temperature volume of the given mass is Gillisack law. The thermal radiations are electromagnetic waves. Predator. When the wave travels from air to the water, of course, during the diffraction of any of the waves, the frequency remains constant, which is the quality. The unit of the power is watt. Power of a lens is diopter, sorry. One of 1 upon reciprocal of the focal length, which is expressed in meters, will say that has been called as the power of a lens, or maybe it's in diopters. Spherical mirror, the relation is F is equal to R by 2. Same question has been repeated. Static electricity is produced by friction or the induction. A glass rod, when it's rubbed on a silk, the electron from the glass rod will be transferred on a silk. The glass rod becomes positively charged. That is electricity by friction. And when one rod, which is charged, placed in the vicinity of another object, which is uncharged, so it is positively charged, so it will attract all the electrons and it will repel the positive charge. So this separation of the charges, what it happens, and the object seems to be charged. Seems to be charged. No, object gets charged. It is because of the induction. Friction and induction is an answer. Which one of the following is a ohmic conductor? I think it's nichrome bar. Electrolyte, I can say their conductivity depends upon the strength of the solution or something. Vacuum tubes and transistor, they more or less same, but their conduction will be controlled by the grid. And in case of transistor, I think it has been controlled by the base voltage. So I won't take it more or less as an ohmic conductor. Ohm's law is valid only for metallic conductors, which looks good. Angle of D is 0 at equator. So let's consider the Earth somewhat as this. I'll draw the Earth a little bit tilted, means somewhat as this. Here is a South Pole and there is a North Pole. So I place a bar magnet over here. The South Pole of the bar magnet will be attracted towards North Pole, and North Pole of the bar magnet will be attracted towards South Pole. And it will stay steady in this way. But only the thing is, the distance of a South Pole from the North Pole of Earth is less than compared to the distance of a North Pole from the South Pole of Earth. So this force of attraction is more and that force of attraction is less. So it won't stay exactly horizontal, but it will make certain angle like this. The angle what it makes with the horizon, theta, that I'll say is an angle of D. So if the magnet is over here, both the forces are equal and opposite. I mean equal. And the angle what it makes with an horizon is 0. So at the equator, the angle of dip is 0. And at the polar regions, the angle is 90 degrees. Is 0 at equator, magnetic equator. Magnetic equator. Geographical equator and magnetic equator, maybe they are same. Do not know much about. Or maybe they are a bit different. Inside the bar magnet, the lines of forces are always directed from south to the north. This is the bar magnet south pole and the north pole. They originate from the south and they terminate into north. But inside the magnet, they're directed from south to the north. It's like this. Well, at the few of the measurements, they comes to the instinct. You feel the stuff or feel the part, whatever you've produced. You spare around 20, 30 years of your life in fitting those kinds of stuff, only those kinds of stuff. And maybe you may not need the instrumentation. Maybe that statement, whatever was made, that whatever you worked as a mechanic since from the last around 20 to 25 years, and you haven't used vernier caliper and the screw gauge, and you don't know how to use vernier caliper and the screw gauge, but you just do it depending on your instincts and all, or whatever it is, then maybe last 20 years of your life you have wasted. The statement is not perfectly true. Of course, a person should know how to use vernier calipers and screw gauge. But something has been provided from the top. If you know how to use that, You may not need more of the instrumentation. You need more of your instincts. The reverse bias is the off switch. Inside the bar magnet is south to the north. That's been done. Never have worked with a particular field, so I do not know much. The scalar product of the vectors. So if the two vectors, A1 is equal to A1I plus A2J plus A3K bar of caps. This vector A bar, I'll say. B bar is equal to B1I plus B2J. It means with precision, how much precise you want it to be. Many of the time, too much of the precision is not expected. At that time, certainly can think about to work with the precision instruments like vernier calipers and screw gages. So when I say A bar dot B bar, it is A1 B1, A2 B2. This is the Cartesian vector product plus A3 B3. And the definition of a dot product A bar dot B bar, it is mod A mod B cos theta. That was like that. Average acceleration as how I referred on yesterday. Initial velocity is u, final velocity is v. Toward the interval, let's say it's over u, whatever it happens over here, velocity changes. But I'll be concerned with only the final velocity v. So then v minus u upon t, that refers as an average acceleration. I'm not concerned with the change, what it happens in between. This change, I'm not concerned. I'll say concerned only with the final velocity, initial velocity divided by time, change in velocity divided by time, which is that's called as an average acceleration. Work energy theorem. Whenever there will be a change in the energy of a system, change in energy is equal to kinetic energy gained by the object, or change in the kinetic energy. That's work power energy theorem. A ball of mass, 0.5 kilograms, speeds at 10 meters per second. A stationary receiver catches the ball and brings it to the rest. Whenever the large force or large magnitude of the force is applied for a very short span, the effect, whatever has been produced, it's called as the impulse. Let's say, suppose if the hammer is used to hammer the nail, it stays in a contact with the nail for a very less time. We'll say that is called as an impulse. So force is equal to change in momentum upon time. So only change in momentum is referred as the impulse, which is force into time. Force, how I'll get it? Ma 0.5, mass 10 meters per second, and v minus u upon t, u is 0. I mean, it comes to 0. Upon time is 0.02. This is force into time. I won't stay with the time, 0.5 to 10, because the impulse delta P will gonna be just force into time. This I'll multiply by 0.02. It will be just 0.5 into 10. It will be half of 10 will be 5. 5 kg meter per second. Kg meter per second will gonna be the impulse. Impulse will have the same dimensions as momentum. Newton's laws of gravitation states that two masses, m1 and m2, if they are separated by the distance r, m1 and m2, if they are separated by the distance r, force is directly proportional to the product of the magnitude of the two of the masses and inversely proportional to the square of the distance, or r square. So basically, force we can write as G m1 m2 over r square. Define elasticity, the proper virtue of an object by which, if the external force is applied on the object, it changes the shape momentarily. But as the external force is removed, internal restoring force they'll set up and it will regain the shape back again. So ability of an object to regain the shape back, we'll say it is called as an elasticity. What's Newton's laws of cooling? It states that rate of fall in temperature, d theta by dt, is directly proportional to the excess temperature of an object than surrounding. Rate of fall in temperature of an object which is hotter than surrounding is directly proportional to the excess temperature of an object than surrounding. What's the common sense about this particular law? Let's say your daily expenditure is around $1,000. $1,000, then it is more. And let's say suppose if you have a money of around $10,000 or 10,000 rupees, there's around 9,000, whatever you have as more. Excess money, whatever you have as more, then your rate of expenditure is large. You might spend, let's say, spend the money with a larger amount. But as the money comes to 1,000 as your daily expenditure, your rate of expenditure starts getting reduced. That's Newton's laws of cooling. In the cold weather, temperature of the surrounding is 8 degrees centigrade. What is the temperature in the Fahrenheit scale? That's a simple equation. Write an expression for the displacement of a sinusoidal wave traveling in the negative x direction. Let's do this. X-axis, y-axis. A sinusoidal wave. It is traveling along with a negative direction. Let's say P is any particular point. It is at a distance x from the origin. The particle at the origin will oscillate with y. They will oscillate in y direction as a sine omega t. Since it is oscillating from the origin, it starts oscillating from the origin. We do not have any of initial force. Initial phase is 0. Particular point P comes in a path of a wave whenever it is traveling from right to the left. Particular point P comes in a path of a wave first. So point P leads and the origin lags. How much it lags? For the distance lambda, the angle is 2 pi. Means when we consider the distance lambda, this distance is lambda. According to the sinusoidal wave, the angle or the phase concerned with that much of it, it's 2 pi. When the distance comes x, it is 2 pi x upon lambda. So it is led by the phase 2 pi x upon lambda. So it will be a sine omega t minus 2 pi x upon lambda. It's not minus. It leads by the phase, so I should add plus. So this will gonna be the equation of a particle in a wave, sinusoidal wave traveling along with negative x direction. A source of sound produces a frequency of 170 hertz. Velocity is equal to f lambda. F is the frequency and lambda is the wavelength. Simply substitute and we get the answer. What do you mean by uniform electric field? If the magnitude of the electric field or the intensity of the electric field is constant everywhere, that is force applied by any particular test charge, let's say anywhere in the particular field is same, then we'll say the electric field is uniform. What are electromagnetic waves? The waves, which is a combination of electric field and magnetic field oscillating perpendicular to each other and perpendicular to the direction of a propagation of a wave, I call them as electromagnetic waves. Which element do you use to make a germanium as a p-type semiconductor? Any pentavalent element I can be used to make a germanium as a N type semiconductor. So maybe phosphorus, it has 5 electrons. Around it, can be used as a impurity, as a pentavalent element. Define doping. To improve the conductivity of a semiconductor by mixing an impurity in a very small quantity so that the conductivity has been improved. The particular fact or the particular process is known as doping. State of the rules of writing the significant figures and significant digits. Decimal places, if there are no digits after decimal places, then the significant digit is only 1. Is only 1. But suppose if it is 2.0005, then these zeros are counted. So 1, 2, 3, 4, 5, 6, 6. Suppose there is no digit 0.0000239. So only 3 decimal places. 3 digits are the significant digits. Find the conversion factor between the CGS and SI for energy. Energy is kg meter square per second square. So 1 kilo is equal to 1000 grams. 1 meter is equal to 100 centimeter square. 1 second square will be 1 second. So it will be around 10 to 7 gram centimeter per second square. 10 to 7 is the factor. Determine the magnitude of V1 plus V2. Just add the corresponding IGKs. It will give the magnitude of V1 plus V2. What is projectile? Any particular object, whenever it's been thrown in the air on the surface of the earth, the motion, whatever of an object is there, which has been influenced by the gravity, I will call as a projectile motion, then the object is called as a projectile. The arrow shot from the bow or maybe cannonball shot from the cannon are the 2 examples. Next. What is the horizontal range? Distance covered on a horizon by an projectile, which is called as a horizontal range. Derive the expression for it. So let's say it's been thrown by the velocity v. Sorry. Theta is the angle. So v cos theta is the velocity along with x-axis. So time required to complete the particular motion is time of flight. So v cos theta into time of flight will gonna be the horizontal range. I use this particular relation. Time of flight, how I find? The motions along with x-axis is given by distance along with x-axis is x is equal to v cos theta. U cos theta or v cos theta, I'm not concerned much. Y will gonna be v sin theta. I'll find the velocities, of course. Velocity along x and y are given by this. I'll go for the displacement along with x and y. The y displacement will gonna be v cos theta minus ut minus ut minus half at square, half gt square. I use this to find the time of flight. In case of time of flight, the object falls back again on the surface of the earth. The y will gonna be 0. So v cos theta TF will go minus half GTF square. TF gets cancelled. It will be 2V cos theta upon G. It's going to be TF. I substitute in here. V cos theta नहीं है. UT मतलब U will be sin theta. Velocity along with y axis, not x axis. So it's a sin theta. Sine. Everywhere there is a sine. V sin theta. 2V sin theta upon G. Everybody's been messed up to express in form. And that was like that. I just substituted this 2V sin theta upon G over here. Sin theta upon G. 2 sin theta cos theta will gonna be sin 2 theta V square sin 2 theta upon G. It's gonna be the horizontal range. Easier how it looks. A car moves with a constant velocity of 60 kilometers per hour. Average velocity is equal to total distance traveled divided by total time taken. Total distance traveled will gonna be 1 plus 1 kilometer. Total time taken will gonna be 1 upon 60 plus 1 upon 40. It's gonna be 200 upon 2400. over 2400. So 12. It's 24 kilometers per hour. Particle moves in a circle with a speed of 15 meters per second. V square over R will gonna be centripetal acceleration. 15 square will gonna be 225 with a radius 2 meters. 122.5 meter per second square will gonna be centripetal acceleration. In case of elastic collision, the total kinetic energy is conserved, total momentum is gone. What are the importance of the Newton's second law of motion? What are the importance? It's important. It gives a relation between the force and the change in moment. What is in moment? Kepler's laws of areas. With sun as a focus, when the planet revolves around the sun, it shifts the equal area in equal interval of time. So when the 2 times at T1 and T2, this area, that area will be same. So when the radius is large, the angle is small, and when the radius is small, the angle is large. That's what the law it means. State the unit of universal gravitational constant. So F is equal to G m1 m2 over r square. F is Newton. G stays as this will gonna be kg square, this is gonna be meter square, G will gonna be Newton meter square per kilo square. Newton meter square per kilo square. So that is the unit. Now let's write the dimensions. Newton is kg meter per second square, Newton meter square is gonna be Newton meter square per kilo square. Kilos gets cancelled. That is LMT. Suppose if I write length is 3, mass is -1, and the time is -2. This must be the dimensions. of a universal gravitational constant. It need to be written in a square bracket. What will be the duration of an year? Kepler's law states T square is directly proportional. Cube. T square is equal to K R cube. T1 square R1 cube. T2 square R2 cube. When the distance is doubled twice, T1 upon T2 square R1 upon 2R1 cube. R पार्टी get cancelled 1/8. पहला 1 बरस बाद में कितना बरस? T2 will gonna be 8 बरस. Define tensile stress. If the external force applied on the wire is responsible to change the measured dimension as the length of a wire, then the stress produced in the wire is called as tensile stress. And the change in dimension, that is change in length upon original length, will say it's called as tensile strength. Obtain the SI unit of a and the dimension of a stress. Force upon area, so that is same as pressure, but of course it's not a pressure. The stress is tensor. And there the next word starts. The force upon area, so kg meter per second square, upon meter square. One of the meters gets cancelled. That is LMT. So what if I'll write? The mass is 1, meter is -1, and T is -2. That looks as a dimension of a stress. Unit will gonna be Newton per meter square. A wire of length of 20 meters and the area this much. Calculate the Young's modulus. The necessary information is of course not at all sufficient to find the Young's modulus. Young's modulus is stress upon strength, so force upon area divided by L upon L. So F into capital L divided by A into small l. So there is no F, but force by which the wire has been stretched is given. And so do not an extension. So think about it. Ask to your professors or maybe the teachers to rectify the particular problem. The aluminum is 2 meters long, 25 degrees centigrade. How much it expands at 25 degrees centigrade? It's the coefficient of linear expansion. L1 is equal to L0, 1 plus alpha delta T. L0 is how much? 2 meters. 1 plus alpha is going to be 2.55 into 10 minus 5. Delta T will going to be 25 degrees centigrade to 125. So its temperature is 100. So it's going to be 1 plus 2.55, 10 raised to minus 3. 10 raised to minus 3 will going to be 0.00255. 1 plus. So it's 1.00255 into 2. We're going to be L1. Do the necessary calculations and solve the problem. Distinguish between the heat and the temperature. Heat is the amount of the energy possessed by the object, and the temperature is the degree of measure of that particular energy. It's called as a temperature. State any two characteristics of the progressive wave. Any two distance between the crest and the trough, it's called as a wavelength. Two particles with the same phase difference will be always in the same state of oscillation. There. The speed of a sound is 498 meter per second in the air. And the gas is 498 meter per second, and the air is 332 meter per second. for the given frequency. What is the ratio of the wavelength of a sound to the gas to the air? It's simple. V is equal to F lambda. V is equal to V1 is equal to F1 lambda. F lambda 1. V is equal to F lambda 2. Just take the ratios. Two of the velocities are given, substitute V1, substitute V2, and find lambda 1 to the lambda 2. State the condition for the total internal reflection. If the light travels from denser medium to the rarer medium, it moves away from the normal. At the particular angle of incident, the angle of refraction is 90 degrees. This particular condition has been known as the condition for the total internal reflection. So the first condition is light should travel from denser medium to the rarer medium, and the angle of incident has to be more than critical angle. Critical angle is the angle of incident. At that time, the angle of refraction is 90 degrees. If the angle of incidence is more than this, the angle of, refracted ray reflects back into the same medium. It's been known as total internal reflection. State and explain the Coulomb's law in electric. Two charges, Q1 and Q2, are separated by the distance r, and the force of attraction or the repulsion between the two charges is directly proportional to the magnitude of the product of the magnitude of the two of the charges, Q1 and Q2, inversely proportional to the distance. The constant, whatever has been introduced in this case, it's called as an epsilon. So the force is given by 1 upon 4 pi epsilon 0 Q1 Q2 over r square. And this is the epsilon, it represents the quality of a particular medium. Epsilon 0, it's meant to be for vacuum. In case of any other particular medium, it has been given by 1 upon 4 pi epsilon Q1 Q2 over r square. Now, epsilon, permittivity of any particular medium to the permittivity of the free space, they call it a dielectric constant. It has got no unit. So I can write this second equation as 1 upon 4 pi epsilon K epsilon 0 Q1 Q2 over r square. Interesting. Let's move on. What is the electrostatic force of repulsion between the 2 point charges? 10 raised to minus 10 and 10 raised to minus 9. So I use a Coulomb's law. 1 upon 4 pi epsilon 0 will gonna be Q1 Q2 over r square. 10 raised to minus 10 into 10 raised to minus 9 divided by 10 meters square. And this is going to be 9 10 raised to 9. 10 raised to minus 19. 10 raised to minus 10. And 10 square. It's going to be 10 raised to minus 12 Newton. Of course, it's a very small force. Karen explains Ohm's law. It states that potential difference applied between the two ends of the conductor and the current, they're directly proportional. The constant of proportionality, they call it the resistance. Do not read any books from Brian Cox. Don't be involved with too much of the cosmology. It just spoils your life. Try to live the normal life. Right now, with the energy crisis, fuel crisis, whatever they're happening, space research is least expected. We should concern more with farming and to sustain the happy life on the land. Earth's magnetic field at the equator is approximately this much. Calculate the Earth dipole moment. Radius of the Earth is this much. Equator, I think it's B at the equator is mu 0 upon 4 pi m upon d cube. Or r cube. Let's take it as r cube now. What else? One upon 4 pi epsilon 0. And this I'll take it as 10 raised to minus 7. This has been given 4 into 10 raised to minus 4 into 10 raised to minus 5 Tesla. dipole moment is need to be find out. D, I take it more or less as an R for the convenience. Convenience, everywhere there is a convenience. 6.4, then this is 6 square. Then Q is going to be the answer. Do the necessary calculation and have fun. State the features of the features of or the properties of the depletion region. Okay. I call that as a migration problem. P-type and N-type semiconductors. So few of the P-types they diffuse into N-type and few of the N-type they diffuse in the P-type. So at the P-type there'll be some electrons and at the N-types there'll be some holes. No. At N-types there'll be some holes, means positive charge. So near to the boundary of the two states, you'll find the people who they speak both the languages. So this is a depletion region. If the P-type is made more positive and N-type is made more negative, the depletion region becomes more and more thin. No. P-type, suppose if it is made more negative and N-type, suppose it's made more positive, the depletion region reduces. P-type connected to the positive and N-type is connected to the negative. The diode becomes conducting, the depletion region becomes smaller and smaller. So in the depletion region, you will find both the charges mixed inside. Here the positive charge is attracted towards N-type. So the whole they get diffused into N-type. So who are the people they'll be in Singapore, they'll tell you, don't come over there. You're gonna spoil the fun over here. Dubai people will say, stay in India, don't come over here. Because then whatever the salary is there, it will be maintained. If you come over here, you will work, population increases, and even will get deprived. That's a strategy of everywhere. That's why everybody should stick to that city or maybe the country. Explain the space propagation. I haven't discussed this. Ground propagation, you have a tower here, second one is over here, and they should be in a line of sight. It's called as in ground propagation. It travels along with the ground. So walkie-talkies, we can say it's a ground propagation. Line of sight, it matters. Once you are out of line of sight, then maybe I think ground propagation won't work. Phase propagation, I think the waves are reflected from the ionosphere, the radio waves, and they can circle around the globe. All you have to keep a relay station over here. Means if in case if the wave need to be sent around the globe, is an ionosphere, it goes over here and it comes back. Then you need a relay station over here, and then the wave can be also circulated around the whole globe. Now, only the question stage now. There are stations now. Now there are certain apps, what they call it in radio garden. Exactly how the all radio stations now they've been broadcasted over the entire globe. Now they said that they use the internet, but how? How means maybe I don't know how. Whatever. Chalo. Calculate the frequency in megahertz of a radio wave, 150 meter long, Remember that. The speed of all the electromagnetic is in vacuum. So we remember that what to remember. It's the fact. V is equal to F lambda. As simple as that. Replacing region is instead. State the applications of the semiconductors. The best application of the semiconductors is to make the processors. How we define the processor? Function of the processor is to process the process. When the process comes to the processor processes the process. And when the process is processed by the processor has been forwarded by processor. That's the function of a processor, is to process the process. Thank you very much. All the chips has been made by semiconductors and maybe solar cells. Define the dimensions and the physical quantity. List the dimensions, limitations of the dimension analysis. Dimension analysis won't give the constants, whatever they're involved. Basically, I mean to say, force of what? Viscous force of on an object or the sphere is directly proportional to the coefficient of viscosity, velocity by which it moves, radius of the sphere. So you can find the powers of these quantities on which the force, viscous force, is depending upon. But the constant, whatever has been involved, I don't know, Mr. Stokes, how he has found that particular constant. The viscous force on the sphere, whatever has been moving through the water, has been given by 6 pi NVR, eta VR. I mean, this 6 pi, I think, purely he has found by experimentation. That's the basic disadvantage of dimension analysis. You can just check the formula and you can find to which power of the particular quantity the things are depending, but not the constants, whatever they involve. What are the errors? Instrumental error and random error. This kind of an instrument, whatever is there, lesser than that, if you measure, then it gives an error that they call as an instrumental error. Random error happens because of the, let's say what, some geographical phenomenon, or maybe the carelessness by the observer. Let's say while measuring the time period of a pendulum, if there'll be an earthquake, or maybe suppose if sudden rise in temperature, then some the simple pendulum increases and the time period may not be measured accurately. Or that some other provisions has to be made and the random errors can be avoided. You want to have a rock and roll? Refer about LIGOs, large interferometer gravitational observatories. How the random errors they have been neglected in that particular observatory. You just read about it and you'll be enthralled. Now, what's the use of this in the human fucking life? That human life is fucking. So, whenever the research has been done to the higher level, those, I say, the factors, whatever they used it at the higher level, when they go much more higher, they'll come to the lower level. And our life becomes more and more suitable. That's why it's been meant for. Find the order of magnitude of the following. 6.10 raised to minus 11, I think 6. It is more than 5, so I'll have to add 1. So it is 10 raised to minus 11 plus 1. It is 10 raised to minus 10. Mass of an electron, still it is more than 5, so I'll have to add 1. Minus 31 plus 1, minus 30. Speed of light in a vacuum, it is in a meter per second. So I'll take a jump. 1, 2, 3, 4, 5, 7, 6, 8. So 10 raised to 8 will gonna be the order of magnitude. What do you mean by resolution of a vector? And how the magnitude of a rectangular components is determined in 2 dimensions. Any particular vector, let's say suppose if it is there, effect of that particular vector in a particular direction will say it's a resolution of a vector A bar along with P bar direction. How I do it? I just stop the perpendicular. This particular length will say it's a effect of this particular vector along the direction. Let's say if the angle is theta. So this will gonna be what? A cos theta. And the perpendicular component will be this. Will be gonna be A sin theta. I'll call them as the resolution of a vector. All we should know that A cos theta and A sin theta, it should include the particular vector. Means this perpendicular direction, I won't take it in the reverse way. Not good, because then the vector doesn't include, get included in both of these components. Define time of flight and all that has been discussed. Let's not waste our time. Waste our time मतलब तुम लोग waste करो, मैं नहीं करेगा. Distinguish between the real force and the pseudo force. Define momentum, state the unit of. Define momentum and state and mention its type. You know, momentum, what types of momentum? Momentum is mass into velocity. Kg meter per second. And maybe grams centimeters per second. That was like that. Check. Linear momentum and angular momentum, I can say that are two of the types. So when the object is moving in a straight line, we'll say it's a linear momentum. When the object is circling, it's angular momentum. Angular momentum is given by I omega. This will be given as mass into velocity. Angular momentum is moment of inertia. It has been given by mr square. Angular velocity is theta upon time. That's angular momentum. Radians per second. Radians per second is the angular velocity. Mass will gonna be kilo, and velocity will gonna be meter per second square. Meter square per second square, and all whatever it comes. Angular momentum. Go to Nehru Science Center if you wish to also feel what they call as an angular momentum. The variation of a force in a given region is given by if it displaces the object from x1 to find the work done. Work is equal to Fs. And you have to find the work. Now, I really do not have any idea whether in maths they have treated or they have taught the particular concept, what they call as an integration. So it is x is equal to 1, like x is equal to 2 meters. F dx. It is the reverse process of integration. So it's 6x squared minus 4x minus 8. I had to integrate from 1 to 2 dx. And you get the answer. Calculate the acceleration due to the gravity on the surface of a moon if the mass of the moon is gm over r square. Is a formula for the gravitational acceleration on the surface of a planet. Mass of the moon has been given. Acha. Mass of the moon is 180 times than that of Earth. Calculate the acceleration on the surface of the moon of a mass. If the mass of the moon is 1/80th time of the Earth. ये Earth का लिखा मैंने. बाद में moon का लिखेगा. Gm upon Rm square. I take the ratio. So Ge upon Gm, mass of Earth divided by mass of a moon. Radius of moon divided by radius of Earth square. This will gonna be 1/80th time. One-fourth. Radius of a moon is 1/4 of radius of Earth. Square. Mass of Earth is 180 times than that of a moon. So it's gonna be 180 into 1 by 16. Diameter and radius means same. Doesn't make a difference. Earth's gravitation is 9.8. Moon's gravitation are at 5. So now दोनों 18. वे 9 18 वे 8 16. And you do the necessary calculation. 90 divided by 45 divided by 4 into 9.8. And we get the answer. Derive the expression for the Young's modulus in the form of an y. Young's modulus is stress upon strain. Stress is the force upon area, and strain is the dl upon L. So it is mg upon pi r square divided by small l over capital L. That will be gonna be mgl divided by pi r square L. That was like that. The wire has been loaded with weight m, and it comes as this. Extension produced in the wire is small l. What do you mean by ideal gas? It obeys all the laws without any confusion. Here is the expression Pv is equal to RT and RT. Pressure is directly proportional to the volume. Volume is directly proportional to the temperature. Boyle's law and Charles' law, let's suppose if they're fused, we get general gas equation. Pv is equal to KT. Pressure is inversely proportional to the volume, not directly proportional to the volume. This is not good. Pv is constant. V is equal to T, Charles' law. Conduction, convection, and radiation. Conduction, heat has been transferred from molecule to the molecule. Conduction, without actual migration of the molecule. Conduction, the molecules, they migrate from one place to the other place. And radiation, it is without any medium, the transfer of heat. Explain the Newton's formula for the velocity of a sound. So V is equal to gamma P upon rho. It's a Newton's formula for the velocity of a sound in the air. Gamma stands for the specific heat ratio of the specific heats. And P is the pressure and rho is the density. State what its limitation. The transfer of a sound has been considered as an adiabatic process. So there won't be any exchange of a heat through the medium to the from the medium to the surrounding. That was the basic assumption is done. In the case of sound is propagated through the air. But I don't think so that is perfectly correct. The man standing between the two parallel cliffs. You can hear the echoes after 3 seconds and 5 seconds. ये cliff building है, दूसरा building है. ये आदमी इधर पे खड़ा है. One echo he hears after 3 seconds and 5 seconds. 3 second वाला echo को इधर जाने के लिए 1.5 second and 5 second को जाने के लिए 2.5. So net time for which the sound travels between both of the disturbances is 2.5 plus 1.5, which is 0.4 seconds. So 4 into time, I'll say what distance? 360. 360 into 4. We're going to be the distance between. Neat level diagram of the total internal reflection. It's been done. Thickness of a glass is 2 millimeters. Refractive index of the glass is 5 meters. Calculate the speed of light in the glass. Refractive index mu is equal to speed in air divided by speed in glass. इसके लिए thickness of the glass why it was given. I still have no idea about. Calculate the Gauss law of electrostatic. Obtain the corresponding relation. This video has been already put. Total normal name. Total flux over the hypothetical surface, which includes the charge, is equal to algebraic sum of all the charges enclosed by the surface. That's what the gas law it states. Obtain the expression for the electric field intensity due to the charge in the medium. If any charge is there, I have to find its intensity at a distance r, means at this particular point. I'll place a test charge over there. Test charge seems to be the small positive charge. The force per test charge is the intensity of the big charge. Force is given by 1 upon 4 pi epsilon 0 QQ over R square. So this intensity, which is force per test charge, will be given by 1 upon 4 pi epsilon 0 Q over R square. It is measured as Newton per Coulomb. It's a vector quantity. Its direction has been given by the direction of the force on the test charge. So suppose if it is both of them, they are positive. I mean, the charge of which we are measuring the intensity is positive, then the intensity moves away. Test charge is always a small positive charge. The ohmic resistance follows the Ohm's law. The ratio of potential difference to the current always remains constant, and the graph is straight line. Otherwise, in non-ohmic resistance, the graph is not a straight line, it's a curve. BB at Great Britain has a very good vibe. You should use that. You'll get all of it. Set the properties of the magnetic lines of forces. They originate from the North Pole and they terminate into small South Pole. They're continuous, there is no break. They apply the lateral pressure on each other. total flux in the closed area, on the closed area, which has been placed in magnetic field, is always zero. It's not like electrostatics. A short magnetic dipole. Calculate the magnetic field at the distance 20 centimeter from the center of a magnetic dipole on its axis and the equatorial line. The dipole, the distance is d. So mu 0 upon 4 pi. Two m upon d cube is for the axis, and m upon d cube is for the equator. Mu 0 upon 4 pi. Magnetic dipole moment is given as 0.5, 20 centimeter from the center. This is given as 20 centimeter. Do not forget to convert into meter. 10⁻². And you get the answer. What is the intrinsic semiconductors? The conductors which conducts the electricity. If in case if the temperature is increased, is known as intrinsic semiconductor. Or the potential difference, temperature or the potential difference between them is increased. It starts conducting at the higher temperature or the potential. We'll say it is called as an intrinsic semiconductivity. The best example is if the bank manager is there, the person who is taking the check is not there. Many of the people have been clogged who they bought the check in the bank to be registered. So the bank manager who is not responsible even to do that particular work, start doing the work. Bank manager, I take it as an example of the person, I mean the electron which is in a stable orbit. तो केबिन में बैठा होगा तो भी वो बाहर आएगा, चलो भाई दिमाग मत चाटो, मैं तुम लोग का चेक ले लेता. That is intrinsic semiconductor. If the potential increases beyond certain value, or maybe the temperature increases, the stable electrons, they starts conducting heavily. It's known as an intrinsic semiconductivity. The law of parallelogram of addition of the vectors. Obtain the magnitude and the resultant of the vector. वो तो मालूम है सब लोग. State explain the different types of fundamental force: gravitational force, nuclear force, and electromagnetic force. A plus delta is equal to I plus E. ये सब पूरा करके जाओ. Even you go for the what? Refractive index also. Obtain the expression for the electric field intensity due to the point charge. अभी जो किया था वापस पूछा. टीचर को बोलो थोड़ा अटेंशन दे दो. चलो, बेस्ट ऑफ लक्स, हैव फन, एंजॉय योर लाइफ. वे लैग होने लगा है, दैट्स व्हाई आई एम मेकिंग बेस्ट ऑफ लक्स. चलो, थैंक यू वेरी मच.